All right, we are talking about absolute value. I want to walk over to the number line and talk about the basics of absolute value because it's something that's not a common topic in high school. But now that we're doing the second half of algebra, we're going to see it. So, absolute value means how far away a number is from zero. If zero is right in the middle, how many spaces away? So if I put my ruler on 5, and I say, how far away from 0 is 5? How many spaces? 5. Just 5 spaces. 1, 2, 3, 4, 5. And then I might go over here and say, I'm at negative 9. How many spaces from 0 is negative 9? 9. But I wouldn't say negative 9 spaces. Just 9 spaces. I could never say, oh, I saw you on the street. I live negative 4 houses down from you. No, just I live 4. Maybe it's to the right, maybe it's to the left. Or I'm sitting negative 1 chairs away from him. No, it's always just the number, the value of the number. So what's the absolute value? What about how far away from 0 is negative 3? Just 3. You're giving a positive answer. So in the objective space, I have some that I want to try. The absolute value is the distance that a number is from 0. So here's some samples that I want to try. The absolute value, I'm going to do it in the objective spot. The absolute value of negative 6. How far away from 0 is negative 6? Just 6, right? Okay. Then how far away from 0, what's the absolute value of positive 6?
6.
Just 6. So I'm counting in positives. And just like this question, I want you to tell me, so here's what I'm going to do. Absolute value of I don't know, and don't answer so fast, okay? Give other people a chance to think and answer. I want to know what numbers could I put into this absolute value and get a positive 6 out? Yeah. I could put in a negative 6. What else could I put in? And I could put in a 6. So either one of these are going to be good. Jennifer. Okay. What values could I put in for x and get a positive 3 out? Not every single question. You have to, no one else has a chance because you rush. Yes.
3.
3 is one choice. X could be 3. What else could x be? Yeah. Negative 3. So there's a positive and a negative version to absolute value. There's the negatives and there's the positives. And we're going to see that in graphing because yesterday, come to the backboard, or look at the backboard. Exponential is what we were working on last chapter. It is y equals 2 raised to the power of x. Absolute value looks like this. This is what we're doing this chapter. Absolute value has a negative side, and absolute value has a positive side. And I graph it using y equals the absolute value of x. So this is the absolute value symbol, straight lines, with an x in the middle, and I plug in values inside those brackets. Now let's do the vocabulary questions. The absolute value of negative 3. How far away from 0 is negative 3? How far away from 0 is negative 3, everybody? New people. 3 away. What's the absolute value of positive 3? 3. Easy. Okay. All right. This is kind of tricky. 4 times the absolute value of negative 10. I have to, yes, it is 40. It's not a race. Just remember that, please. The absolute value of negative 10 is just 10. So I can just say 4 times 10, and you all said 40, which was correct. Do the absolute value math first. Last one. Forget about the 3. What is the absolute value of 1 take away 5? Negative 4. So the absolute value of negative 4. What's the absolute value of negative 4? 4. So now I'm going to put the 3 in front. I first do the math, and then I put the 3 in front. That would be 12. Positive 12. All right. We're going to start graphing. We're going to plug in values for x. Always small. -1, 0, 1, like super small. And look, -3, -2. This is called the parent function. This means that the shape of this graph is going to base, all the others will be based off this shape. So I might move this graph to the left 4, up 2. I might make it skinnier or fatter, and we'll talk about those things today. So let's practice it. F of x is the same as y, and my equation is absolute value of x. So we're plugging in values. The absolute value of -3, what's that? 3. Keep going down the row. The absolute value of -2, what's that? 2. The absolute value of -1, what's that? 1. Let other people.
Sorry.
Okay. So it's just the positive version. Absolute value of 0, someone new. Just 0. Absolute value of just 1. 1. Absolute value of 2. 2. Absolute value of 3. How far away from 0 is the number? All right, please plot these points, and you'll notice that it's like a perfect V shape. -3, 3. 3 to the left and up 3. Make a dot. -2, +2. 2 to the left, up 2. -1, +1. 1 to the left, 1 up. 0, 0. 1, 1. Over 1, up 1. 2, 2. Over 2, up 2. This V shape is perfect. Yep. This is called the parent function because there's no numbers after it, in front of it. It's just the original absolute value. Notice where my 2 lines, upward and downward, intersect. That's called the vertex. 0, 0 is my vertex. It's a perfect V shape. It mirrors itself. And what I mean by that is, if I were to draw a line down the middle, it would match up. Left and right would be symmetrical. So I'm going to draw my, maybe not in green. It's hard to see. Axis of symmetry. X equals 0 because it's a vertical line. Up and down, x equals 0. Let's talk about domain and range. It's been a while. This arrow means it's going to go forever up, 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 up. This graph just goes like this. So forever positive. Oh, that's negative, isn't it? Forever negative. Forever positive. To negative infinity. So I'm going to scan my pencil left to right. Domain. Yes, it would be here. Yes, 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 yes. It goes upward now. Yes, yes, yes. This is all negative infinity all the way to positive infinity. We call that all real numbers. Remember, negative infinity, comma, positive infinity. All real numbers. Range. Range goes from low to high. If I'm going to have negative infinity way down here, then I'm just going to slowly scan upwards. Higher, higher. Nope, not there. Nope, 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 nope. Oh, it hits it here. This is the first time my graph is appearing. So nothing in the negatives. But it starts at 0. And then it goes 1, 2, 3, 4, 5, 6, 7. Positive infinity. So I'm going to say from 0 and I'm going to put a bracket. We haven't talked about this since last chapter, but a bracket means that the 0 is included. That means it's a closed dot on the 0 line. 0, comma, all the way up to infinity. Infinity always has the parentheses. That's a rule about infinity. It has to have parentheses. It can never have a bracket. Bracket means included. There's no dash line. It's like a solid circle at that number. Okay. Now I'm going to start playing with this x. I'm not going to give you just a boring parent function x. Now I'm going to put a negative sign in front of it. So let's turn the page. Does anybody have a thought on what a negative sign is going to do? What would it do to a graph? A negative sign in front.
It would turn it.
Would turn it, but it would make it, it would turn it. And let's find out how. So, negative. Oh, you know what? I need to first draw my parent function. I'll do that in pencil. That's the same as last example on the front page. It's just upward increasing. It's a V shape, guys. So my parent function is this that I'm doing right here. It's what I just drew on the front page. 1, 1, 2, 2, 3, 3, and the symmetrical side. -1, 1, -2, +2. So it goes from my vertex over 1, up 1. From my vertex over 2, up 2. From my vertex over 3, 1, 2, 3, up 3. It's symmetrical. It's a V shape. But now I'm going to do in red negative x. The absolute, negative absolute value of -3. Woo! The negative absolute value of -3. Inside first, what's the absolute value of -3? 3. But there's a negative out in front. The negative stays out in front. All right, moving along. The negative absolute value of -2. -2, good. The negative absolute value of -1. Just -1. Good, you're catching on. What about -0, huh? Yeah, we can't do, there's zero's not negative, zero's not positive. Negative absolute value of 1. The negative goes in front. Good call. The negative absolute value of +2. -2. The negative absolute value of just 3. -3. So now you plotted the parent function, yes? We're going to plot the parent function every time. Parent function, where my original absolute value of x, what it looks like. All right, plot these new ordered pairs. 3 to the left, 3 down. Okay. 2 to the left, 2 down. It's still linear. 1 to the left, 1 down. 0, 0. My vertex is 0, 0. So this negative sign flipped it downward. 1 to the right, 1 down. 2 to the right, 2 down. 3 down. Okay. It looks upside down because it was reflected. Because it was reflected over the x-axis. The V-shape got flopped downward. Let's do my axis of symmetry. It's the line that would cut this V shape in half. It still is x equals 0. Domain. Scan. Just my red. Look at red. Scan left to right. Yeah, it hit negative infinity. Yeah, it goes to positive infinity all the way to the right. All real numbers. Negative infinity to positive infinity. Range is low to high. Start low. These red lines go forever. I could go crazy with this red line thing. So it's way down here in negative infinity. Negative 100, negative 50, negative 10, negative, yes. Oh, but then it stops. Red line only. It stops at 0. That means there's a bracket at 0. Okay, negative infinity is going to be in parentheses, comma, 0 bracket. Negative infinity, comma, 0 bracket. Bracket means 0 is included. It has a solid circle, solid dot. There's such things as open dots. That's why. All right. So I put a negative sign in front of it and I reflected the whole graph downward. Number 3. I'm going to put a 2 in front of it now. The graph, f of x equals 2. I'm doubling the size of my, multiply the parent function y values by 2. I am multiplying the y values by 2. So whatever I got for my answer originally in the parent function, times 2. 6, 4, 1, 2, 2, 4, 6. We need to use the parent function to multiply the y values by 2. So, you can do, I'm going to have to multiply everything by 2. All right, 2 times the absolute value of negative 3. 2 times the absolute value of negative 2. 2 times the absolute value of negative 1. 2 times the absolute value of 0. So now I'm doubling. The absolute value of negative 3 is 3. 2 times 3 is 6. Absolute value of negative 2 is 2. 2 times positive 2 is positive 4. 2 times the absolute value of 1. 2 times 1 is 2. Or I could write it. Let me write it because I think that whatever I can do to help, right? 2 times 3. 2 times 4. 2 times 1. It is not 2 times 4. That is so wrong. Well, if you were kinder about it, I mean, like, give me a grandpa. It's like a little monster lion. Give me a grandpa. But I do that when people find my mistakes. I absolutely. Ooh, let me erase it before someone said it. I made another mistake, and I like, oh my gosh, I'm gonna lose all my money. 2 times 1 is 2. 2 times 2 is 4. Okay. I want you to graph the parent function first. Good job. All right. Please graph the parent function first. I'll do it in pencil. Parent function. This is my basic, boring 1, 1, 2, 2, 3, 3. Okay. In red, I will do my new. All right. Negative 3, comma positive 6. So this is going to change. The 2 is a stretch. It stretches it. -3 up 6. Oh, it's off the graph. 2 to the left up 4. -1 up 2. Zero, zero. Over 1 up 2. This 2 definitely affected how my graph looks. Over 2 up 4. Over 3 up 6. This became narrower. Connect the dots. La, 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 la. So this 2, any whole number, a 2 or a 3 or a 4 of the absolute value of x makes it skinnier, narrower. A whole number. That's what a whole number does. Have you guys noticed something about the order pairs? How like -1 and 1 match up? 2, 2. The x values match up 4, 4. Have you guys noticed that? Because they're symmetrical. 6, 6. Even up here, up above, it's the same thing. My domain is going to be the same. It goes from left to right. -infinity to positive infinity. All real numbers. My red vertex, I better do it in red, is 0, 0. My range. It's not in the negatives. No, no, it's not in the negatives. Nope, nope, nope. Oh, it starts at 0. That's where my red line starts. That's a bracket. 0, comma, infinity. Parentheses. Be careful. Axis of symmetry, x equals 0. Okay, I doubled the y values. I multiplied 2 times all the y values. It got a narrower, skinnier graph. Closer, and I think that's important to write, closer to the y-axis. Look how it got like pushed inward. Closer to my y-axis. Last one is 1/2. What do you think 1/2 is going to do? If 2 makes it skinnier, 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 what's a 1/2 going to do? Wider. A fraction makes it fatter. It's called a vertical shrink. I'm going to multiply all my y values by 1/2. Cut them in half. So, 1/2, 1/2. Times the absolute value of -3 is 1/2 times 3. Okay, table of values. Here we go. What's half of 3? 1.5. Half of -2. What's 1/2 of 2? I have 2 and I cut it in half. 1. Uh, 1/2 times -1. Half of 1. I have $1 and I cut my dollar in half. 50 cents, 1/2. 1/2 times 0. is 0. 1/2 of 1. Oh. Because they're all going to match up. You could actually predict the rest of your answers because you know that you're going to get this. Matchy, 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 matchy. 1/2 of 2. 1/2 of 3. Absolute value of 3. You could also write 1 and 1/2 as a fraction if you don't want to write 1.5. All right. You need to graph the parent function first. Parent function is the original V shape. Over 1, up 1 in both directions. Over 2, up 2 in both directions. Over 3, up 3 in both directions. And then you need to graph your new. And we'll make some observations about what changes. This is my normal absolute value of x. Over 3, only go up 1.5. 1.5 is in between 1 and 2. Halfway box. Over 2, up 1. Over 1, up 1/2. 0, 0. Over 1, up another 1/2. Over 2, up 1. Over 3, up 1.5. Okay. So, what happened to my, let's make some observations. Tell me what happened to the red. The red got what? A 1/2 or 1/3 or something like that. It gets wider. It's fatter because a fraction does that. A fraction makes things, expands it outward. Yeah? All the math is related. The domain, scan it from left to right. Negative infinity, yes, 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 yes. Positive, positive, positive infinity. Negative infinity to positive infinity. All real numbers. My range. Nothing in the negatives. No, 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 no. Oh, it starts at 0. Bracket. 0. Up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, la, 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 positive infinity. Up, up, up. Low to high. And then vertex. Obviously 0, 0. Axis of symmetry, the line, straight down the middle, which is in green, and you can hardly see it. X equals 0. All right. Notice the patterns. The numbers are the same. Yes? It's a pattern. It's symmetrical along the vertex. And the axis of symmetry cuts it in half. So I will stop the recording.